Hi everyone, good morning or good afternoon, depending on where you're located. We'll be starting in just a few minutes, just to let a few other attendees come on in, so just sit tight. I will just mention now that we've got a few panelists online. They're waiting to answer any questions you have. So if you have any questions now or throughout the webinar, feel free to send them in as you think of them. The panelists will either answer them for you, or Seth and I might wait until the end and answer them for the benefit of the whole group. So yeah, just a few minutes and we'll get started. Hi everyone, we're just waiting for a few more participants to join. We'll be starting in 1 minute or two. So just wait for a couple of others to join. There's a few of you wondering if you're having audio problems. So hopefully you can hear this, and just sit tight for 1 more minute or so. All right, I think we might kick this off. So yeah, good morning, good afternoon. Thanks for taking some time out of your day to join this webinar today, presented by Biarri Networks and OSPinsight. So just a couple of housekeeping items. You are able to answer or to ask questions throughout the presentation via the Q&A feature in the Zoom webinar. We have several panelists that are waiting to answer those questions, so feel free to send them in as they come to mind. If they don't answer you during the webinar, it might be that we're just saving that to the end, and Seth and I will address those questions for the benefit of the whole group. And then the second item is just that there will be a recording available after as well, if you'd like to share it through your organization. So I think we'll just start with an introduction for Seth and I. So my name is Patrick Edwards from Biarri Networks. I'll give you some background on Biarri Networks. We began developing software for designing the national broadband network in Australia about 8 years ago. 5 years ago, we began focusing on the United States, and we provided design services for large-scale fibre to the home projects since then. The way we design fiber optic networks is a little bit different. We use algorithms to speed up the process, along with a team of designers who know how to collaborate with those algorithms, as well as adjust them when needed. 2 years ago, we began developing our web-based product, Fond. And the aim of Fond is it puts those algorithms in the hands of engineers so that they can speed up their own design process. So I work as a product manager for Fond. And so part of my job is to carry out research on what our customers need to do in Fond, and learn a bit about how we can solve their problems using a mix of algorithms and GIS tools. I'll be paying a lot of attention to the questions that come through during this webinar. So again, I'll just ask you to please send through any questions as you think of them. Finally, I also work with partners like OSPinsight to help ensure that once our customers are happy with their design, that they can move it to the next stage of their project without needing to spend time redrawing designs or losing any information. So with that, I'll leave it to Seth to introduce himself. Seth, over to you.
Thanks, Patrick. Hello, my name is Seth Strayer. I'm the solutions engineer with OSPinsight software. And for those of you that aren't familiar with OSPinsight, it is the system of record software for your fiber optic network lifecycle. This includes planning, design, operating, and monitoring. And as the leading software application for fiber optic network management, OSPinsight provides our customers detailed information about every physical aspect of your fiber network by maintaining a relational spatial database and displaying that information in both tabular and graphic formats. And so again, thanks for joining us. And today we will cover the ecosystem of software products in the fiber optic network development space. We hope to impart how you can understand the flow between different products. Importantly, how to leverage auto design with tools like Fond, and how the result of that can then be implemented into a fiber management system like OSPinsight. So what we're really concerned with in the development of fiber optic networks are these stages that we're all pretty familiar with, from planning to design to construction and system of record. And OSPinsight handles these separately, but we also identify efficiencies where we can make the system better. And that's where we look to partners like Biarri Networks, where we can then focus on specific areas or detailed areas of the workflow or the work stages. So today's presentation will focus primarily on planning and design, where we leverage Fond and Biarri Networks engineering services, and take that output and then thoughtfully add that to your OSPinsight database. And we do that through a thoughtful workflow. And this is something that we've been in development for some time. And the concept is one where we can take your system of record database, and from that we can create a descendant database that would be used for the construction phase of your workflow. And perhaps a descendant database of that construction database would be a database for design. And the way that we see this working is we would take the structured design output from a tool like Fond, or even from Biarri Network Engineering Services, and import that into a descendant database of your system of record and encapsulate that within a work order. That work order then becomes the method of promotion from stage to stage. So you can take that high level design or even low level design, depending on the quality of the output and effort put into that initial package, and refine the data in segmented stages. And that gives you the ability to also report on those stages. So you have a real-time view of how your network is being developed.
Thanks, Seth. So yeah, hopefully that gives you a bit of a high-level overview of how the data flow can work within between FOND and OSPinsight. What I'm going to do now is kick off a demo that both Seth and I are going to work together of both of our products. So the first thing I'll sort of say is this is just maybe a little bit of a different sort of demo. I'm going to try to present this in the context of a real life scenario. So we're going to sort of put this in a story where we'll be an in-house engineer at a small to medium telco who's looking to carry out a feasibility study for a new area in Utah. So the engineer's primary objective for this is to determine the cost to serve an area. But their secondary objective is to do that in a way where they can incorporate some local knowledge into that cost estimate. So I'm just going to jump over to FOND oops, spoilers, jump over to FOND to kick that off. So give me one moment. So you can see here FOND is just running in my web browser. It's a web-based fiber network design tool. I'll start off by clicking the new project button to create a new project. So every time you want to make a new design, we start a new project and we'll give that meaningful name. So I'm going to call this project SLC Design V1. So the engineer is doing their first iteration of this design. So in FOND, there's a 3-step process to creating a network design. The first step is to select or configure an architecture. The second step is to bring in your input data. I'll go over more about input data later, but essentially that's telling FOND where are all the subscribers located and what are the valid paths that you can take to connect them. And then the third stage is clicking the generate design button, but also then bringing in some field knowledge to make the design more accurate. And that's where we'll iterate on the design a little bit. So I'll dive into step 1. So select architecture. The architectures essentially tell FOND what equipment it can use and how it can connect together. So we can see on the left here, we've got 3 existing architectures that our team has already put together. But what I can do is create a new architecture as well. And I'll give this an architecture name. I'll call it SLC architecture. What I'm going to do now is tell FOND what are all the rules that it needs to follow when it's generating this design. So FOND designs from the bottom up. The first thing it does is it designs the drop tier. So we call that tier 1. And when FOND is designing the tier 1 of the network, it's connecting all of the homes back up to a drop closure or a terminal. And it's doing that in a way that it tries to minimize the amount of equipment it uses while also respecting some rules. So one of the rules that it needs to respect is a maximum drop length. So I'm going to adjust that to be 500 feet. What that means is that FOND can run a cable no more than 500 feet from the home to the subscriber location, from the subscriber location back up to the MST or the terminal. I can also specify that if there's no more than say 5 handholds or flower pots between the home and the MST as well, if we wanted to enforce the number of hops that it can make. The second constraint for the drop tier is setting the maximum number of homes that can connect back up to that terminal. So in this example, I'm going to use a centralized split architecture. So I'm going to do that with a 2. We're going to allow 2, 4, 6, 8, or 12 port terminals. And I'm going to set the split ratio to none because we're going to split back at the cabinet in this centralized split architecture. I could set a split ratio of 1 to 2, 1 to 4, or 1 to 8 if I wanted to though. In this architecture, I'm going to leave a couple of spare ports. So while we're going to have a 12-port terminal available, the maximum number of subscribers that we'll see is 10, just to allow some spare for future growth. And I'll connect those ports back upstream as well. So the fibers coming out of those ports will be lit. So now I'll move on to tier 2, commonly called the distribution tier. So this tier is we're gonna set the capacity of the fiber distribution hub or the cabinet. I'm going to set the capacity to be 144 or 288. So FOND is going to try to use as few of these as possible, of these cabinets as possible. So wherever it can, it's going to use a 288 port cabinet. But if there is a smaller amount of demand, it'll drop it back down to the 144. We've already got the cable sizes specified here. I'm going to just add a 288 fiber cable that we can use as well. And I'm going to set a bit of spare in the cable. Now we've got spare already at the tier 1 hub, but I'm adding 20% spare here as well So 20% of that fiber cable now will just be purely reserved for spare. In the hub, I'm going to add a 1:32 split ratio. So being a 288 port cabinet, we'll have up to 9 1/32 splitters there. And I'm going to leave 10% spare as well. So we should see about 29 ports remaining spare on a 288 port cabinet, and we'll connect those upstream as well. We have some parameters here for the parallel cable threshold. What this allows us to do is to reduce the amount of splicing that gets carried out in the network. It's common to see a cable running out of a cabinet maybe 100 feet down the street and then branching to the north and the south. Now, when it branches, you can do that in two ways. One is to place a splice closure there to physically branch the cable into two new cables. Alternatively, we could run the cable in parallel for 100 feet to save some money on that splicing. So depending on what your splicing and cable costs are going to be, we can tune this parameter. A common parameter that I see users using is about 500 feet. So that allows them to reduce the amount of splicing in the network at the cost or the expense of having a little bit of extra parallel cable. Now, I'll just mention here that we do have the ability to use connectorized tier 1 closures. So if you're using something like the CommScope MST, we could use connectorized tier 1 closures where we set a maximum tail length for that closure. So we could set that up to 1,500 or 2,000 feet and a maximum number of tails per splice. But for this demonstration, I'm just going to go through with a really standard, fully spliced, centralized split architecture. Now, the final tier, tier 3, so this is often called your feeder tier. I'm going to remove the 576 cable. We won't use that. We'll keep the amount of spare to be 20%. And I'm going to use a much longer parallel cable threshold in this case here, a 1,000 foot parallel cable. So thinking back to the story that we're in, this is an in-house engineer at a telco doing this. So this could be an architecture that they use in all of their existing markets that they're benchmarking on, or it could be a new architecture that they're testing out to serve the unique geography for Salt Lake City. So they could be experimenting with a new architecture or just using the stock standard architecture that they use in all of their markets. So I'll click use, and so that architecture will be saved to this project. It also gets saved to the account, so the engineer could now go back to a different market and use the same architecture without having to go through that process. So step 2 is bringing in the input data. So we hear from a lot of our users that they have trouble getting subscriber locations, especially in the early stage of their project. So we have a feature called Area Select. And what Area Select allows us to do is source data without having to go to the utility or to the city to obtain that data yourself. So I'm doing this demo in Salt Lake City. So let's go to Salt Lake City. All right. So once I've found the area that I want to design in, I can start drawing a polygon. So I'm just going to draw this polygon to follow this road here, carving out a certain neighborhood that's going to form the basis of our feasibility study. So we're just going to do a small sample area just to see what the costs are going to be. What the engineer might do later is a much larger area, but especially when you're testing a new architecture, it is good just to choose a small area like this. The other reason I'm doing a small area like this for the demo is it'll take about 5 minutes to run. Any bigger, like if we were to do an area of 10,000 homes, it could take 20 to 30 minutes, and I don't want you to have to sit through that. So I'm just going to do this small area. I think it's about 1,000 homes. What Fun's doing now, it's pulled down all the parcel data for this area, so we can see these land parcels, and it's also pulling in the underground path data. So this underground path data, this is just the street center lines for the area, and that's going to form the basis of our candidate network. So these are candidate paths that Fon can use to run its cables along. So I'll import both of those. So we have now the minimum amount of data that Fon needs to generate a design. We've given it an architecture, and we've given it the addresses and the underground path. Another bit of information I'm going to give it though is the central office location. So I'm just going to draw that on the map like so, and click finish. So before I hit design, I'm going to have a look at the network and just look at my candidate network and make sure that everything's in a good space. One thing I've noticed here is that I've drawn the polygon in a way that has missed this major road here. And so FON's not going to be able to run a cable down there. So I'm just going to go back and adjust that. So the engineer's doing the right thing, and he's looking at his input data to make sure it all makes sense. The input data is what's going to decide the outcome of the design. So it's really important to spend a bit of extra effort up front and just make sure that that's correct. So what I'm going to look to see is just to make sure that I've got the underground path running along here. Almost. Just going to drag that out a bit further. There we go. So now I've got the underground path running through here. So that's going to connect, the cables now will be able to connect all these other neighborhoods there. Glad I didn't let that one slip by. All right, so now we can move on to the fun step, hitting the generate design button. I've got all my input data in place. I've got my architecture set up. I can hit generate design. So as I mentioned, font it designs from the bottom up. And it does this in a way that tries to minimize the total amount of equipment. So what it's doing now is it's taking all the input data and it's converting it to what is basically a giant mathematical equation. Once it's finished creating that equation, it starts to solve it. And the first part of it that it's solving is the part around the drop closures and the drop cables. So it's trying to use as few drop closures as possible and as little cable as possible, but it needs to respect those rules. It can't just place one drop closure to serve the whole area. It has to place drop closures in a way that you have no more than 12 ports with 2 spare and no more than 500 feet from the home back to the drop terminal. Once it's finished connecting all of the homes back up to a drop terminal, it can move on to the next step. So the next step is to place the cabinets. When it's placing the cabinets, it's doing a really similar thing. It's trying to place as few cabinets as possible. And it's trying to do that in a way that respects those constraints. So again, it can't just place one cabinet to serve the whole area. It's going to have to place, I think in this area, there's 1,000 homes. So it's going to have to place about 4 cabinets probably, because we've got that 288 port cabinet. So that's what we expect to see come out at the end. When it's connecting cabinets, if we were doing an architecture that had connectorized drop terminals or NSTs, that's also the stage that it would be determining where to place any splice closures. And it's trying to do that in a way that minimizes the amount of splicing. So if we were designing MSTs, this would actually take a lot longer because it's not only solving where the cabinets are placed, but also how the MST tails get brought back together in a way that minimizes the amount of splicing in the network, which is after all, the whole point of using a connectorized solution. Finally, once it's finished determining the cabinet locations, it runs the feeder cables from the cabinet back to the central office location that we drew. And then the final step, it's going to count all the materials and the costs. So I'll show you what that looks like in a moment with the bill of materials. So I'll just give this a few more minutes to run, a couple more minutes hopefully. Seeing some questions coming in, which is good. If you've got any questions about how FOND works or why we design from the bottom up, feel free to send them through. So this design is now finished. So what I'll do is I'll dig into the design a little bit. And so the engineer at this point has said, great, I've got my first layout of what the design is. They can go and have a look at their costs. So they're saying based on the costs that they've provided with the equipment that they've uploaded, they can see that their cost is going to come out at about $2 million for this area. So these are just demonstration costs. Every user of FOND has their own version of these. So the engineer checks that and thinks, okay, that's ballpark. All right. So they're going to move on to the next stage of the design. They're going to say, let's put this in reality. The first thing they might notice is say, I'll have a look at the tier 2 cabinet location. So we've placed this cabinet just here. Now the engineer might know that they can't get a team through here, or it's just a bad place to put a cabinet. So what they can do is just click move equipment and drag it back down the street. So FOND's done its best to place a cabinet in a place that it thinks is going to minimize the amount of cable, but the engineer knows better. The engineer knows that they can't put a cabinet there, and this is a much more realistic place to put it. So that's what we're doing here. And that's when I talk about collaborating with algorithms, that's one of the ways that our users do that. they let Fond sort of have the first go at it, and then they'll provide new information to encourage Fond to do the right thing. Another thing I'm noticing here is we have cable running down this little street here to serve this cabinet. Now, the engineer might know that this is a bad road to have to install cable along for whatever reason, so they can then go in and tell Fond to avoid it. So I'm going to click on that street segment there and say avoid. So Fond, being, you know, an optimization engine, is going to try to avoid this, because what I'm saying to Fond here is you're going to have to pay more money to use that section of road. So Fond will have to pay a cost of about 10 times more to run a cable through there than it would to run through here. And I can also, if I want to give Fond some extra encouragement, I can say prefer this. So now Fond is going to get a discount for running down this section here. So I'll click on that section there as well and say prefer. And I'm going to apply those changes. So the second time that Fond is running now, it should run a little bit quicker. The reason why is we've taken out a lot of the decision making that it has to make. So Fond spent a lot of time thinking about where to place the closure locations and where to place the cabinets. What we've done is said to Fond, the locations you've chosen are fine. We move this cabinet down the road to this location. So now all it has to think about is the cable paths. So it's rerunning those same solvers, but just choosing the cable paths now. And it has new information. So we're going to see a new design. The information it has is that it needs to avoid this section here. Now, Fond could still choose to run a cable through here if it made cost sense, because all we've said to Fond is it's more expensive to run through here. If we really wanted to tell Fond not to run through here, we could just delete the underground. So you can physically go in and just delete a section of underground path, and Fond won't be able to run a cable along it anymore. So this will come down in a couple of seconds, I think. We'll see, hopefully, the cable not running down this road, but running through here. And that's what we see here. So it's avoided this section here, and it's routed the cable through there. So the engineer would spend a lot more time than I have going through and reviewing the design. They would even do things like going through and moving the equipment at the drop level. So they might prefer the drop closure goes further this way. They can spend a lot of time just tweaking and adjusting that design. At a certain point, once they've brought in all the information that maybe is from the field, they've done a field validation run, they've decided that the design is good to go, that's when they move that design to an alternate system. So Fond specializes in design. That's why we work with partners like OSPinsight, who specialize in the management of networks. So at this point here, the engineer, who also uses OSPinsight in this instance, could share the design with OSPinsight. So I'm just going to share this design with Seth. So I go share project. I'm going to say Estrella. That's fine because I use Seth's old email address, and hit add. Now I can say Seth can have read and write access or just read only. In this case, I'm just going to say read only. I don't want him to make any changes to my design, and I'll hit save. So that sends Seth an email, and he can now go into Fond and bring that into OSPinsight. So Seth, back over to you, and I'll let you continue the rest of the demonstration.
Perfect. Thank you, Patrick. So I think Fond is clearly an incredible tool, and especially useful for prospecting and generating very quick, high-level estimates. And that was our initial appeal to it, but it's capable of so much more than that. So as we receive that project, and this is for full transparency, within OSPinsight, we do intend to build a tool where we can download this data directly from Fond and have a programmatic import that would push that into a connected OSPinsight database. And in that same vein, what I'm going to show is a process that we programmatically converted it using a suite of manual tools that we have, with the intent of just being able to complete this through the webinar. But I think that once we log into that network, this will all make sense. So initially, when I log into OSPinsight, I'm presented with all of the networks that I have access to. And the primary user interface for OSPinsight Web is the right click. So in this particular example, I've imported that data into a, a descendant database of my production demo database, city test. And we'll go ahead and open that now. Oop, there we go. So you can see the same network that we generated in Fawn that Patrick had just sent over is now represented in OSPinsight. And if you're not familiar with OSPinsight Web, especially as this is a relatively new offering, and what we're doing at this initial zoom level is we're creating raster tiles of the cable plant. So you have localization detail of where that cable is placed, but we're not drawing all of the GIS data to the screen at this time. That's a significant performance increase. And the end user has complete control over when that data is made available by selecting the layer control and then setting the zoom level for when that map data is drawn to the display. So as we zoom into this area, once we hit those predefined zoom levels, you'll see the actual OSPinsight elements draw to the map. And from here, I can interrogate any of these elements. And I think that this particular platform, and that has a similar look and feel to Fond, will ease the impact of getting your users or yourself accustomed to using OSPinsight. So there's some artifacts that we maybe didn't clean up in that initial build. So I see that we have a parcel record to an empty lot, maybe not necessarily build to that, and a number of parcel records that aren't residential or wouldn't be serviceable. So within OSPinsight, we can go ahead and just remove these from our design. So we'll update the termination panel or the CPE. We'll take out the cable span. We have the ability to edit. So there's a term panel here going to a house that we may want to position, and in the tree cover, you may not see it. So we want this to be as accurate as possible. So we'll just continue to update and refine this design and say that the CPE or the point of entry is going to be on this side of the building. And you'll see how the cable snaps directly to that particular termination panel. The real power of OSPinsight comes in the ability to test this network too. So we can sanity test this design, and I can come into a cabinet where we have a termination panel. I can pull up a list of ports. And from this list of ports, I can select any of these and it can generate a detailed route report. So we're doing two things as we create this route report. We're highlighting the path on the route, on the map rather. So you can see the area that this particular port serves. And then you can see all of the elements that are used within that route, including links and losses as you go. So this gives you just another form of validation. And then you can see the effect and output of each of your splitters along this route. So there's two ways to symbolize this, but also a third way in generating a route schematic that gives just another kind of single line diagram or single line drawing of the connectivity of that particular route, where I can see from the source building or cabinet, the term panel, the port, the distance to my first splitter and my drop layer, the distance from that drop layer to each of these endpoints. And along this route, if I have any question about the splicing or the configuration of any of these materials, I can simply right click in the route report or on the map. And once I right click, I access this contextual menu that is network element category specific. So if I click on a splice point, I don't have to sort through menus for cable spans or term panels. I can just find exactly the information that I'm looking for and pull that up quickly to understand what's happening at that particular location. If we do a more detailed example, if I want to see the area that's fed by a particular cabinet, I could go to, in this example, the feeder panel and pull up a port list. And here, this is where I have a feeder fiber feeding into a 1x32 splitter that then feeds that distribution panel. And this is a bit of a larger query, so it'll take a second, but you'll see the result is pretty quick. And I can see the entire area that's affected or served by this particular panel or cluster. And as we zoom in, we can see those endpoints. And now I can really understand the refinements that I would need to build this, where the fawn tool selected the center of the parcel. I now want to make these cable length adjustments to where I'm actually going to build to. Let's say the neighborhood that we've designed to changes over the next couple of years, and the demand is increased. At any point, using the tools within OSPinsight, I can select an individual cable span, and from here I can generate a taper report. This is going to show me the complete utilization of any cable within our network. So as we do this, the taper report itself is unique in that it examines that cable in both directions. So this is showing that I have a number of dead fibers within this enclosure, and the status of being dead means the fiber is present at these enclosure sites, but it's not spliced through. And where I do have spliced through, it will show me the endpoints that are served in both directions. So in the case of the yellow arrow on fiber number 6, in one direction I start at my distribution cabinet and I work back to my feeder cabinet. So I see my my splitter that feeds back to my feeder cabinet. In the other direction, I see from that splitter out and all the endpoints that are served by fiber number 6 from that particular location. And then to step back to the earlier slide where we talked about our workflow, this data is actually imported into a descendant database of our system of record. And if I want to see that system of record database, I can easily turn that on or display that at the same time, because I'm not designing this as a standalone. I want to integrate this or tie this into my production network. And we have the mechanism, the capability of doing that. This is where you love live demonstrations, right?
Oh yeah, they're the best.
It's always one of those things. It doesn't help that I'm extremely nervous and it seems like seconds are taking minutes, but
Yeah, no, I've been there.
So for whatever reason, that's not going to draw. We'll give it a second still.
It seems to be taking a regular amount of time from my point of view.
So the sweat pouring off my forehead isn't an indication of time. That's good to know.
Yeah,
Anyway.
yeah, exactly.
So everything from fiber utilization to refining this plan to being able to support this and then having the documentation to go back and work with this network ongoing are really the features that I wanted to highlight in this presentation. And I wanted to do it with our new tool, OSPinsight Web. And I think this is the way forward for us, certainly. But all of this data is also fully supported within desktop applications as well. And with that, I think we do have a few questions.
Yeah, there's been a number of questions coming in while you were demoing. I've seen a couple. Do you want me to maybe answer a couple and you pick through and find some for you?
That'd be great.
Yeah, okay, cool. So first question that I've just on top of the list, do distances on the reports include tail footage on MSTs? Yes, so the BOM can be configured to count whatever your inventory is. So if you're using, as an example, 500 foot, 1,000 foot, and 1,500 foot MSTs in your inventory, that's what the BOM will report. But if you wanted to break it out every 100 feet, you can do that as well. A couple of questions that are related are about our input data. So where does FOND find the road data to follow? It just uses OpenStreetMap data. We update that quarterly. You can upload your own data as well. So if you didn't want to use the OpenStreetMap data, or you had existing plant that you wanted to follow, you could upload that. And then the other question was about parcel data outside of the United States. So as you noticed, we only have parcel data in the United States. We are looking to acquire it in other markets. So if you've got interest there, that will help with our decision making there if it's important. But even if we can't access it for you, you can upload your own. So if you're able to work with your local city or county or municipality or telco to get that data, you can do that and upload it into FOND. So you've got some options there. And then the other one was that someone noticed we were just using underground routes in this design. Does FOND consider overhead, like attaching to existing utility poles? Absolutely. I think maybe next time I do a webinar, I'll show how that works, but you can just upload any poles that you have, as well as any spans that connect those poles. And that's what FOND will follow when it's running on the cables, rather than following the underground. And it'll of course display that cable count and cable cost differently in your bill of materials to reflect different labor costs there as well. So that's a few that I found. Seth, have you got any questions that you wanted to answer?
Yeah, there was a question whether or not OSPinsight was Esri based, and it certainly can be. We do have a version of desktop that supports Esri and is integrated with ArcMap. And web can also be a client to that same database. So within Esri, you would have a geo database, whether it's a personal or enterprise geo database. That database, OSPinsight Web, would just be a client to that same database. And then there was a follow-up question to that, whether OSPinsight could be a standalone application. And I assume that the question is for web, and it definitely can. OSPinsight Web itself is a relatively new product that we soft launched late last year, and it does not yet have feature parity with desktop, but it's very close, and we're closing ground on feature parity to the point where there's some features that are in web that don't exist in desktop. And that's because of the way that we developed web. We wanted a GIS that we had full control of and didn't have to interoperate with a middleware vendor to display or access our database.
Seth, I've got a couple more I can answer that have just come through. What is considered in project cost? Is it just construction? If it's just, yeah, the bill of materials can be, essentially the way it's configured is you send us what you want a bill of materials to look like with all the rows that you've got, and then in a couple of months you'll have the ability to configure that yourself. So yeah, you can make it just be construction costs for materials. You could also have it reflecting labor quantities as well. As long as you can think of a rule that maps from the design that you see on the map to a row in a spreadsheet, you can generally have that happen in your bill of materials. And then there was a question about MDUs. Someone asked if the engineer is able to override the number of fibers that a building gets. So yeah, you might have noticed that all of the address points had, I'll just quickly show what this looks like. All of the address points had just a single amount of demand next to it. So what I can do is actually go in here and just say, we're going to make that be 10. And a lot of the time this, did that go through? Did you listen to it? Save. So now that building now needs to get 10 units worth of demand. So that'll probably get some unsplit fiber to it. But often this data that we get in many areas does include MDU data. Probably can't, oh, here we go, here's one here. It's some sort of duplex. It's a property, it's been given 2 fibers at this hospital. So you can go in that as well if you wanted to have a larger amount of demand. Seth, any questions you want to go back over?
No, I think that's it for us. We've seen a number of questions, and some of them we'd like to follow up with each of you that have asked. So we'll make an effort in the following day or two to reach out to you individually for the questions that we weren't able to address during this presentation.
Cool. All right. Well, I might just go through the little wrap up that we've got here. So share my screen. So yeah, we just wanted to recap what we've done today. So we covered how you can create a network design for about under 1,000 homes in 10 minutes. So we did that by using Area Select to pull down data from Fond, and then we adjusted a few things like cabinet locations and splice closure locations, and then we said that was good enough. So we did that in about 10 minutes. Usually the engineer would spend a longer amount of time going through and making adjustments to the design. Once they've done that, they've taken that from being initially a research level through to what we would call a high level design, where the design is more realistic. And once it had reached that level of fidelity, that's when we make the decision to export it into OSPinsight, where Seth then goes through and can make some finer tune adjustments and manage the splicing there. We did the Q&A. All right, well, so that's all we had for today. So thanks so much for joining. So these are our contact details here. If you've got any other questions that you didn't get answered through the webinar, we've seen there's been a couple of others that will come through. We can answer those directly, or you can reach out to Seth and I directly as well. Our email addresses are here for you to send through any questions. So we really look forward to hearing from you. Thanks for joining. Seth, anything from you to close out?
No, just thanks for your time and attention today. We do appreciate it.
Great. All right. Well, thanks again. And David, I guess David's behind the scenes, can close the webinar.